Hello guys, good afternoon. So today I'm going to talk about decorator pattern and how they are actually implemented in Python as Python decorators. So decorator, as the name suggests, is associated with decorating something, in general objects or functions, and we have different ways of doing it. One way is with inheritance. Inheritance, we know it's just creating a simple class, extending it as required in its subclasses, but it makes the extensions very tightly coupled with the base class, and any changes but any the I mean cannot be dynamically used by the client. So any changes to the extensions cannot be dynamically used by the client basically. So to explain this problem, I'll take an example. Let us assume we go to a car shop and ordered a car, blue colored car. That means in programming terms, it's like you can assume a class. Oh, sorry. So you can assume vehicle as the base class, car as the inherited class, and colored car as another inherited class of car. So we create a class colored car. Now what if after the car has been instantiated, after the colored car has been instantiated, what if we want a car with spoiler? Then we have to scrap the colored car or the implementation of colored car and use the colored car with spoiler here. So it is actually making things complex, or there are a lot of changes needed when you want to change something with respect to the usage of a class itself. Now, but so what? Now what? So we have, so there are problems with subclassing as such. So extensions cannot be added dynamically whenever needed, and if any new extension is added, a lot of change needs to be done at the system level. So now we have decorator pattern. So with decorators, there's a class car, and we can have color and special wheels as two different decorators. So we can add them dynamically. So what decorators helps us is, it actually helps us add individual responsibilities to individual classes, independent objects independently, and it requires to be done without adding any extra code. That's so simple, and we can create a large number of different independent extensions across the business logic. Now, I mean, you can assume the creation of classes. For example, they're different. A car comes with different features. So with each feature, if you start creating a class, the possibilities are endless. But with the decorators, each special feature can act as a decorator here. So now coming to Python decorators. So before going to Python decorators, we need to understand that Python functions are objects, and Python functions can be created inside another Python function, and a Python function can return another Python function, and we can pass functions as arguments to another Python function. So we can see this in this code snippet. So if you look at this, this getTalk is a Python function, and this define_shout is a Python function defined inside getTalk. And if you see this return shout, it's returning a Python function here, if kind is shout. And finally, if you see talk equal to getTalk, that means getTalk returns a function, and it is assigned to an object, assigned to a variable here. That means Python function can be assigned to an object here. And if you see the execution, print of talks, if you print the talk, it outputs a function, Python function. And if you print talk inside a function, it inputs, it actually executes the function, returns the function returned. And yeah, so we come to Python decorators here. So it has a simple syntax that starts with @ and it allows to wrap a function or method in another function and modify the arguments or results here. There are two types of decorators here, function decorators and class decorators. and we'll see how function decorators are here. So yeah, each decorator here contains a wrapped contains a different contains another Python function inside, and it actually, I mean, when you decorate this function hello with make bold, this wrapped function will be executed first and then executes hello. That's how it is. And yeah, we can decorate functions with parameters here. And if you see, smart divide is a decorator which has an inner, which has a function inner inside the function, and it takes two arguments here. And when you apply this decorator to divide a comma b, they are passed as arguments to inner, and the function execution itself is dependent on how the values are passed. And if you see, if b equal to 0, it actually doesn't return any function. If that is not 0, it returns the base function itself, divide. So we can chain the decorators. Actually, you have we have two decorators here, decorator functions here, star and percent. And if you chain the decorators, they are executed in order. So the order is very important here. And finally, class decorators. So we don't need to actually decorate each and every function of a class. You can decorate a class with one function, and it applies to all the functions in a class. For example, if you take this as an example here, so I have one decorator function, time all class methods. If you want to time all the methods in a class, you can just decorate the class itself, and it will be applied every time the function executes for the object of that class. And if you see here, it starts decorating, starting the timer, and finally it prints the time it took to execute the function. Now there are the few caveats to use of decorators here. It actually slows down the function time it takes to, function call basically, and you cannot undecorate a function. There are ways to do it, but generally it's not suggested, and they are a little hard to debug. So basically we have a Python standard library, functools.wrap, which helps in debugging the Python decorators. And yeah, that's all I have. Any questions? No, if you apply a decorator, right, it will be applied every time if the function is called. Let's say dynamically you can't. Let's say you have star here which is applied to printer here, and you cannot actually remove it easily. There are ways to do it, hacky ways. Yes, it did. It's a decoration, yeah. Any other? Okay. Thank you.